Good morning, everyone. Today, this is the 6-1 to 6-5 review video, and here is my idea. I would like for y'all to grab a calculator, grab a piece of paper, and do some practice problems with me. And so the way I think it should happen is I'm going to show you a problem. You press pause, you do the problem, and then press play again and see how you do. So the rest of this chapter is a little, it's getting away from radicals a lot. So I think we should have a 6-1 to 6-5 test. And so more details on that later, but this would be like a practice for that. All right, so here are the first two questions. They want us to find the real roots of these two numbers. So press pause, do that in a calculator, and then press play again. All right, so since these are numbers, both of these problems are just numbers, these can be done in a calculator. Now, if you press it in a calculator and you get something super funky, then it may be that it's not a perfect square to take a square root of, or it's not a perfect cube to take a cube root of. So if you get something real crazy, then try something else. Okay, so when you take the square root of 0.25, you get 0.5. So this answer is 0.5. And then this one, make sure you know how to do a cube root in a calculator. You have to tell it that it's a cube root, and you have to press second and that raising to a power button, that caret button, and that gives you a root other than a square root. And -1. Now sometimes calculators don't like roots of negatives, even though -125 has a cube root. Sometimes it gives you trouble with, I've found that, I think it's when there's a negative in a fraction, it gives you trouble, but this one did fine, -5. All right, question 2. So again, pause the video, try this, and then press play. I won't keep telling you that. That's the idea. Each question, you pause the video, try it, and then press play. All right, so this is a square root. If you don't know the square root of 16, that part can be done in a calculator. So press square root of 16, and you get that that's a 4. And square root of k to the 10th. So I would like for y'all to be able to do this without writing out 10 k's. But if you need to, no problem. I'm not going to judge you. Just write out 10 k's, and you're looking for twins because this is a square root. If you don't see a little number here, it's a square root. So some of you got real good at just dividing this power by this root. So 10 divided by 2 is 5. So k to the 5th. So what's happening is there's 10 k's, and when you look at a list of 10 k's, there are 5 pairs of them because we're looking at twins. So I'm not going to write out all 10, but just pretend. So these two would bring out 1, and these two would bring out 1. And if you had 10 of them, that would happen 5 times. All right, now there is a picky little rule about this. Whenever you take an even root, square root, of an even power, 10th power, and you get an odd power result, that is the even, odd rule. And technically, we're supposed to have bars around this part right here, just the variable part. So that's the answer. If you accidentally leave that off on a test or something, I will just write that in for you. Friendly little reminder, that really should have bars. All right, here's the third one. There is no cube root of 25. The only thing in there is a 5 and a 5. So the rule about radicals and operations is that you do the operation first, and then you simplify it. So this would be cube root of 25 times 5, which you can do in a calculator if you want to. That is 125. I would test this out to see if it has a perfect cube root, because then you may not have to do the whole breakdown thing and look for triplets. So cubed root of 125. And this one is nice. Cube root of 125 is 5. So this answer is just 5. So if the problem has all numbers in it, I would be checking it in a calculator before I go through the process of breaking everything down. All right, this one. So again, you multiply before you simplify. Multiply first, then break it all down. So 5 times 6 is 30. 180 times 2 is 360. And then this, I would check it to see if it's a perfect square, but that thing is not. See, you would get this ugly decimal, which we do not want, okay? That's what tells me I have to do the whole breakdown, look for twins thing. So over here, 360, 2 goes in there, 180, and I knew that, 2 times 180. And that goes in there, 90. 2 goes in there, 45. 2 doesn't go into 45, but 3 does. And 3 goes into 15, 5. I'm stopping at 5 because that's prime. And then I'm gonna look for twins because it's a square root. So a 2 comes out, a 3 comes out. Now there's already a 30 out there. So if you bring out a 2 with a 30 and you bring out a 3 with a 30, then that's, I'm gonna write that here, times 2 times 3. That would be 60 times 3, which is 180. So 180 came out. And then what's left in there is that 2 and that 5. So square root of 10. And that is your answer. 180 square root of 10. Here's example 5, or question number 5. So same thing, you gotta do the operation first. Now these are cube roots. So it's a cubed root of 4 times 6 times 9. And so 4 times 6 times 9, 24 times 9, 216. Making sure I did that right, 216. And then if you have 2 x's and then 4 more x's and then 1 more x, you have 7 x's. So the rule is when you're multiplying, you just add these little powers. So there's 2 of them, then there's 4 of them, then there's 1 of them. Okay, now we have to do the whole breakdown thing. I would check this to see if that's a perfect cube. So cube root, oops, I put 3 square root. Cube root of 216. That is 6. See, if I got an ugly decimal, I would do the breakdown thing and look for triplets. That's a 6. Now, there's 7 x's in there, and I'm looking for triplets. So, again, if you need to, write them all out. You don't have to, but sometimes it's easier to see it. Cube root, looking for triplets. 1, 2. So 2 come out, and 1 is left in. So 2 x's come out, 1 x is left in. Now don't forget, this is a cubed root, so you have to have that little 3 in your answer. And since you have a power right up next to a root, a lot of times they'll put a times in the middle or just a big old space. So that is the answer there. That's number 5. Okay, number 6. Now we're getting into some, oops, I left this off. Yeah. Now we're getting into some division. Okay, if they're both under a radical, you can divide it. So we can divide 24 by 2, and that is square root of 12. That is not the final answer because there's twins in there. And if you don't know your perfect squares, just test it out. Square root of 12. See, you get this ugly decimal number. That is not what we want. So that's what tells me I have to break this thing down. 12. 2 goes in there, 6. 2 goes in there, 3. These twins bring out a 2. So this answer is 2 radical 3. The 2 comes out, the 3 stays in. All right, number 7. Don't forget to pause the video and try it, and then press play. Since they're both under a radical, you can divide. So 20 divided by 5, that is 4. One thing to be careful about is don't lose your radical too soon. See, I haven't taken a square root yet. I've just divided. You don't lose the radical until you actually take the square root of the number. All right, here, that x on the bottom, that x, is going to cancel with one of these x's, and that's going to leave x squared. And then there's a y on the top, and there's a y on the bottom, and that cancels. And again, this is not done because it's a square root of 4, and there are twins in there. Square root of 4 is 2, and square root of x squared is x. Now, that even, odd rule just happened. I took a square root of a square, so even, and then this is x to the 1, so technically we should have bars around that. All right, number 8. See how these match? All right, the difference in this problem than the ones we've been doing is there's a subtraction. The next couple problems we're gonna subtract and add. Well, when you're multiplying, they don't have to match. See how I multiplied these? 4 times 6 times 9 and x squared times x4, they didn't match. But to add, those radicals have to match. So this is that section where we did, what I wrote on the board was like 2 stuff minus 7 stuff, like that. That's what's happening here. 2 of something minus 7 of something is -5 of that something. Now, the only problem is the ones we initially didn't have simplifiable stuff under here, but square root of 9 can be done. Square root of 9 is 3, so you can bring out a 3 with the -5. So that is -15. Square root of x can't be done. There's only one x in there, no twins. So it stays in. And that is the answer there. So square root of 9 is 3. The 3 came out with the -5. Number 9. These things do not match. So a square root of 4 cannot add to a cube root of 4. So this just is not simplifiable. You cannot simplify this. So cannot add because their roots don't match. And you can't make this square root match this cube root. Okay. On the back. Ooh, I just realized I lost one of my papers. Okay, number 10. Okay, so remember they have to match to be able to add them. And they don't match, but these two over here can be simplified. So this one can't be simplified. I'm just going to leave that guy. This square root of 4 is 2, so that's a -4. This square root of 63, if you do square root of 63, you get this ugly decimal. So that is not what we're going to do, so you get this. So we need to break down that 63 to see if anything comes out of it, and maybe it'll match with the square root of 7. So let's look. 63. Oops, sorry. All right, so 2 doesn't go into 63, but 3 does. And you get 21, and then 3 goes into 21 7 times, and then you look for twins. There's twins right here. So this 2 was already out there, and we're bringing out a 3 with that 2. So that's a 6, and what's staying in the radical is this 7, square root 7. Okay, now we have 2 that match. This guy matches this guy. 7 of these minus 6 of these is 1 of these. So it's 1 square root of 7. And then this guy, it was just a normal number 4. It doesn't match the radical 7s, so you just bring him on down. -4. And that's your answer. You can leave off the 1 if you want to, or you can leave it, it doesn't matter. Number 11. When this says square, which means this whole expression times itself. Okay, so one thing you can't do is just square this and then just square this separately. You have to write it out like this. 7 plus radical 2 times 7 plus radical 2. And so we're going to FOIL this. 7 times 7 is 49. 7 times radical 2 is 7 radical 2. Radical 2 times 7 is another 7 radical 2. And radical 2 times radical 2 is just plain, oops, that's not an equals, that's a plus, just plain 2. Because radical 2 times radical 2 is radical 4, and that's a 2. And then we can combine some things. We can combine the 49 and the 2, which is 51, and we can combine these two middle guys because they have matching radicals, 14 radical 2. And you can't add those. You can't add a normal number 51 to a radical. Okay, the next couple problems are rationalizing a denominator. So pause and try those. To get rid of this cubed root on the bottom, we have to have 3 of them. So we need a cube root, and we need 2 5s in there. And whatever you put on the bottom, you must put on the top. So on the top, you have that 2 on the outside, and you have a cubed root of 25. And we know that can't break down because here's what's inside it. A 5 and a 5, there's not triplets. Down here, the whole reason we did that is because now we have triplets, so we can bring out that 5. So that's the answer. And if this divided, I would do that. Like if that was a 10, I would divide it by 5, but it doesn't divide, so we just leave it. Now this one, see this I rationalized because it was a radical all by itself. I rationalized it this way. But when you have a radical and another number added or subtracted with another number, you have to use something called the conjugate. So the conjugate of 6 plus radical 2 is 6 minus radical 2. Whatever you do to the bottom, you must do to the top. So on the top, we're going to distribute. This would be 6 radical 5 minus, when you multiply these, radical 5 times radical 2 is radical 10. It's still in a radical because you're multiplying two numbers that were in radicals. So they're still in a radical. Here, you can FOIL this, and it'll get you the same answer that I'm about to get. Whenever I see conjugates, you do a shortcut. You square this one, which is 36, and then you put a minus. It's always a minus because they're conjugates. And a positive times a negative gives you this negative. And then you square this one. Square root of 2 times square root of 2 is 2. And it always gives you this nice number like this. 36 minus 2 is 34. It always gives you a nice number. It's the whole point of using a conjugate, so that those radicals cancel, and it gives you a nice number without a radical. All right, number 13. 13, this section is where they introduced fraction exponents. So remember, the bottom number is the root, and the top number is the power. So you get 13th root of x seventh. They just want you to rewrite that, that's all. Just rewrite it. If it was simplifiable, I would go ahead and simplify, but since it's a 13th root and there's only 7 things, that's as far as you can go. And this one, they just want you to do it backwards. So rewrite it in that form. So remember, this is the root. So that goes on the, I lied, that's the power, sorry guys. That's the power, so it goes on the top. This is the root, so it goes on the bottom. So it's x to the 3/5. That's how to rewrite that. In on this test, this review, and this eventual test, whenever you see all numbers in the problem, try it in a calculator, because it's very possible that the calculator does this. So 243 raised to the 4/3 power. Ew, gross. So this did not work, but I think I punched it in wrong. 2 raised to the 4/3. Oh, nope, it's just ugly. All right, So here's what this means. This means cubed root of 243 raised to the 4th. That's what that means. Okay, so I thought this was this number had a cube root. That's what I thought. Let me just double check, y'all, because I thought I picked one that had a cube root. It does not, so that's why this thing's ugly. All right, so let's change this number. I know that's terrible, y'all, but I wanted y'all to see one that came out pretty. So change that to 216. Then try it again. So then I wouldn't need to do that. I was trying to pick one that came out pretty. 216 raised to the 216 raised to the 4/3 power. Yeah, see, I meant for it to be like that. 1296. Okay, the number I had before, if it doesn't come out pretty like that, we would have to take the cube root of that number by doing the whole breakdown process and then raise that to the 4th. But I won't be giving y'all ones where you're taking things that are left in a radical and raising it to the 4th. So that's why I changed that problem there for you. All right, so I have some more, but I lost them in my stack of papers. So y'all take a pause for just a minute while I grab that next sheet. All right, here we go. All right, we have a few more. So this says to multiply, which we did some kind of like this. It was, let's see, number 3 was kind of like this, and number 5 was kind of like this. The only problem is we've got a 5th root and we're multiplying it by a cube root, and you can't do that. So to multiply, the radicals don't have to match, but their index does. Their index has to match. You can't multiply a 5th root times a 3rd root. So this is the whole reason we have fractional exponents. X to the 1/5 times x to the 1/3. This is what we need them for. So whenever you're multiplying like bases, you add the powers. So you grab a calculator and you add 1/5 plus 1/3. Unless you're really good at adding fractions and you just want to add them by hand. It's good practice. You get 8/15. So the answer is x to the 8/15. And you can leave it just like that. If you want to rewrite it as 15th root of x to the 8th, you can. All right, the last section we did was solving equations. So, and that's the whole point of doing all this stuff with, all the stuff we've been doing with radicals. The whole point of it is to get to this point where we're solving equations. All right, so to solve, you isolate the radical. In this case, the radical's already by itself. That radical's all by itself. And then you raise both sides to a power. Since this is a square root, we're going to raise it to the 2nd power. And so the square root and the square undo each other, and you have x minus 2. 5 squared is 25. It equals 25. And then you just add the 2. X is 27. Okay, this one, same kind of problem. You isolate the radical. The radical's by itself. So we're going to raise both sides to the same power. And this one is a little more complicated. So the square root and the square, they still undo each other, x minus 2. But this, you can't just square that and square that. You're squaring x minus 4. So you're doing x minus 4 times x minus 4. And when you distribute, x squared minus 4x plus 16. So you get this. You get x squared minus 8x plus 16. Okay, we have ourselves a quadratic over here. Quadratics need to equal 0 to solve them. So you're going to subtract x, and then you're going to add 2. We're moving everything over here. So the x minus x cancels, the negative 2 plus 2 cancels. That gives you a 0. This is minus 9x and plus 18. And then you factor this. So factors of 18, 1 times 18, 2 times 9, 3 times 6. We want a negative 9 in the middle. We want it to multiply to be positive 18, and we want a negative 9 in the middle. So to do that, both of them are going to have to be negative. And the 9 is going to come from here. So negative, negative. So negative 3 times negative 6, they multiply to be positive 18, and they add to be this negative 9 right here. So here's how this factors. This factors to x minus 3, x minus 6. And then when you solve them, when you set that equal to 0 and that equal to 0, you get 3 and 6. Now, since there was an x over, our original problem had an x over there on the right, you have to plug these in to make sure they still work. So to make sure you're not getting extraneous solutions. So plug them in. Square root 3 minus 2 equals 3 minus 4. So I plugged in a 3 right here, and I plugged in a 3 right here. And you get square root of 1 equals negative 1. Square root of 1 is 1. So that's extraneous. And when you plug in a 6, square root of 6 minus 2 is 4. Square root of 6 minus 2, square root of 4, yep, and equals 6 minus 4. Square root of 4 is 2, and 6 minus 4 is 2, so that worked. The answer is 6. All right. You have to isolate the radical first. So this is weird, but it doesn't look like a radical, but this is a radical. It's a cube root. You have to isolate it first. So move the 2 over, add 2, and you get this. You get x to the 1/3 minus, or equals 8. And then you raise both sides to the same power. Since it's a cube root, you raise it to the 3rd power. And that gives you just x, because the 1/3 times the 3, that's a 1, x to the 1. Or in other words, you can say that they cancel, because that's 3 over 1, and those cancel. And 8 to the 3rd, 8 raised to the 3rd power is 512. And then the last one looks really hard, but it's actually one of the easiest types of questions. So these are radicals. You have to isolate the radical. I isolate this first one. So I'm going to move this one over. So I'm going to add this whole thing. And that cancels. And so you have 3x plus 1 raised to the half equals 7 minus 3x raised to the half. So there's a square root on both sides. That's what the half power means, square root on both sides. So we're going to square this side, and we're going to square this side, and it'll cancel on both sides. That's what makes this kind of an easy question. It looked really complicated, but what winds up happening is pretty easy because it cancels on both sides. And then you just solve this 2-step equation. Y'all been doing that for a long time. Add 3x. So you get to this point in the question where it's just stuff you've known how to do. And then you subtract 1. 6x equals 6. Divide by 6, x equals 1. Okay, I wanted to show you guys this because this is where I got some of these sample questions. There's a website that went with an old edition of my textbook. It's called phschool.com. And if you go there, and it'll ask you for a code, and if you type in this code, it pulls up an old edition of this textbook. And in the old edition of the book, this stuff was chapter 7. It's chapter 6 now, but it was chapter 7 back then. And there are lesson quizzes and there are tests. So the first 5 sections of lesson quizzes are problems just like this that you could try if you want. So that if you're needing some extra practice, you can do that. It's not required, of course, but it's there for y'all. And it does have problems mixed in that are harder than problems we've done. It's got some graphing, but I would just skim over and only try problems that look like ones we've done. So if you're interested in some more practice, that is there for you. All right, so I hope that helps to just bring some of it together. And probably, I think I have it planned for Friday to have a test over this that'll look kind of like the one we just did. So yeah, I hope that helped. All right, y'all have a great day. Later on today, I'll post a review video, or maybe tomorrow, of some of the practice or some of the homework problems that we've done lately. So be on the lookout for that if you have been needing some to go over homework. All right, well, y'all have a great day, and I'm looking forward to seeing y'all relatively soon. Okay, bye.